Today, we're going to solve a specific type of quadratic equation. We'll explore how expanding a squared binomial can help us find the solution. Here's our equation. X squared minus the quantity x minus 1 squared equals 0. Notice that this equation contains a binomial expression raised to a power. To solve this equation efficiently, we need to first expand the squared binomial term rather than trying to factor immediately. Let's focus on this squared binomial term, x minus 1 squared. This is the expression that we need to expand to simplify our equation. A squared binomial follows the pattern of a minus b squared, which expands to a squared minus 2ab plus b squared. In our case, a is x and b is negative 1, so we'll get x squared minus 2 times x times negative 1 plus 1 squared. By expanding this squared binomial, we'll transform our original equation into a standard form that will be easier to solve. This is a common technique when dealing with quadratic equations that contain squared binomials. Once we expand the expression, we'll be able to simplify and solve for the values of x that make this equation true. This will show us how algebraic manipulation can reveal solutions that aren't obvious in the original form. Looking at our equation x squared minus the quantity x minus 1 squared equals 0, we need to expand the squared term to proceed with solving it. To expand the squared term, we'll use the binomial square formula, which is a powerful pattern in algebra. This formula tells us that whenever we have a quantity a minus b squared, it equals a squared minus 2ab plus b squared. This is a pattern worth memorizing as it appears frequently in algebra. For our specific expression x minus 1 squared, we can identify that a equals x and b equals 1 in the formula. Let's substitute these values into our formula and expand the expression step by step. The first term in our expansion is a squared. Since a is x, this becomes x squared. The second term in our formula is negative 2ab. When we substitute a equals x and b equals 1, we get negative 2 times x times 1, which simplifies to negative 2x. The final term in our formula is b squared. Since b is 1, this gives us 1 squared, which equals 1. Remember that any number raised to the power of 2 is that number multiplied by itself. So by applying the binomial square formula, we've expanded x minus 1 squared to be x squared minus 2x plus 1. This type of expansion is essential for solving many algebraic equations. With this expansion, we're now ready to substitute it back into our original equation